Okay, well, there we go. Like you know, I'm Justin Gata. Welcome to my study for understanding some of the lessons of English that I'm going to teach you. So today will be the lesson about the. Yes, we are going to continue the lesson of yesterday that was about the power plant. So we are studying the power plant and the sources of energy from this power plant. No, the sources of energy that are used by the power plant. So this is a lesson that is very rich because you have to study many things, a lot of kinds of the power plants. Yesterday we studied the review about the first lesson that was about the prime movers. We studied the prime movers. I said to you that the prime mover, this is just a kind of machine that converts all the forms of energy that can be thermal, hydroelectric, or anything like that. The heat energy, for example, or the water energy, or even the potential energy. So these types of energy to mechanical work. So this is a machine that is designed for making this type of things. So it is really important because for every power plant, like I said, to the definition of a power plant, this is a system at which the heat energy or even any forms of energy like that are converted into mechanical work, and then the mechanical work is converted into electrical energy. So this is important to make in sort of the energy firstly will be converted into mechanical work. So we use the prime movers. So the prime movers can be the, yes, we can talk about the internal combustion engine, that can be the actuators or anything else like that. So they are just designed uh, to convert our heat energy in the kind of the thermal power plant or any forms of energy like that into mechanical work, and then the mechanical work will be converted into the electrical energy through another device that can be the generator or the condensator or some things like that. So it depends. And I told you also about the about three kinds of types of energy. I told you about the thermal, no, three kinds of the power plant. I told you about the thermal power plant, the hydroelectric power plant, and the nuclear power plant. So that was a very rich lesson. We studied that for the thermal power plant, they are just using the heat energy. Uh, yes, so the combustion of the fuels and the steam that is generated by this combustion to make uh, yes to make that into mechanical energy, and then the mechanical energy will be converted into electrical energy. So they are just using, this is about the way, in fact, the fuels that you are using. So for these fuels, it can be yes, the fuels, for example, the diesel or the kerosene that are used in the internal combustion engine, or even that can be the coal. Mostly this is about the coal. The coal was invented by just in the yes, in the first centuries of the industrialization. So we use the steam that is just released by the coal or anything else like that to make that into mechanical energy. So this is really important to understand. And then yes, it is really important. And yes, we studied more details about that. I said you that it will be converted to mechanical energy using I would say using some of the devices like that. Because the prime movers, you have to know that there's two kinds of the prime movers. You have the reciprocating prime movers and the rotating prime movers. For the reciprocating prime movers, we can talk about the internal combustion engine, the actuators or some things like that. For the rotating, these are, for example, the gas turbine, yes, the gas turbine or anything else like that. So for the thermal power plant, they are using the, yes, it can be for the reciprocating prime movers that can be used to convert that into mechanical work, or even a rotating. We can use the gas turbine for using the steam that is released to convert that into mechanical work. So just using the rotation of our turbine for generating the energy, the electrical energy. So yes, and yes, it can be that, or even it can be just for the internal combustion engine, just to make that just white. So it is not using the rotation, the rotation of the of yes, the rotation, just that the energy that will be released will make the rotation, will just convert mechanical work. No, this is just reciprocating, so just line by line. This is directly like that. not by doing some of the rotation or something like that. Just line. So in the line, just in the line. Yes, and we talked about also the hydroelectric power plant. So for the hydroelectric power plant, they are just in the difference with the thermal power plant. This is about the water that we use, the shaft power that is generated by the water pressure and the kinetic energy. So the kinetic energy or the pressure of the water will make the rotational motion in the case of the of rotating the prime mover, or even to make in sort of, yes, the pressure will just be used in the prime mover for making the mechanical work, and then the mechanical work will be converted into the thermal, into electrical energy, to thanks to the generator. So in fact, there is not any difference just with the thermal power plant, because it can be any actuators that we can use. In fact, this is almost for any power plant like that. We can use any prime movers, that depends, but it will not change anything. But and the difference is just located about the types of energy that you are going to use. So the types of energy that you are going to use for this case will be the water. So the water, the pressure, say, and the kinetic energy that is related to the generated by the water will make our power plant working. And about the nuclear power plant now, I said you that for the nuclear power plant, we are just using the nuclear energy that is released from the radioactive materials, uh, just due to fission reaction, and then we are going to utilize this energy to generate a superheated steam that will just boil the water, and then the water will release the steam, superheated steam. So superheated steam, why? Because the steam is very heavy. This is very heavy, so we are using that for, yes, for making the, yes, for we are using that to convert that into mechanical work, and then to convert that into electrical energy. And now about the components of the nuclear power plant. So the components, we have the, firstly we have the fuel. So the fuel will be the uranium or the plutonium, so that depends. And yes, for the uranium, you have just the uranium that we can take in the nature directly, and then you are going to use this material, and use the fission of the neutrons of this material to generate the heat. But it can be also some of the uranium that we can just put into some of the conditions to make that, I would say, more useful for us, and also less dangerous. It is really important. For the nuclear power plant, you have to know that the materials are very dangerous. So this is important to put some of the shielding that will protect us from the radiation releasing by this type of materials. So for taking these materials, you have to use the shielding and some things like that. And yes, we have also the shielding. The shielding that we just put, because this is about the fission reaction of the materials, of the radioactive materials. So it is important to take into account that the shielding will protect us from this fission reaction, because even this fission reaction is very, yes, it's very dangerous for us. It releases a lot of energy, and yes, the fission reaction is also radioactive. So the shading have to be, mostly we use the shading of 60 meter of 60 centimeter. Uh, yes, of the, you know, of the wide, the wide like that. And we use 60 centimeter for just making the fission reaction occurring inside of the system. So this is really important to take into account. And what again? We have also the control rod. So for the control rod, let me see. The control rod are just using the control rod. Yes, it is important for me to give most of the details about this lesson, because I don't want that you become a little bit confused about the lesson. The controller, the function of the controller is to start the nuclear chain reaction when the reactor is starting from cold. to maintain the chain reactor at steady state condition and to shut down the reactor automatically under emergency condition. Yes, so the control rod will be used to put our reactor into the cold condition for what we stop the reaction just as as more as we want. So because yes, because like they said here, some of the emergency situation will occur even in the fission reaction. So it is important to have the control about the fission reaction like that. And you have also the moderator. The moderator is just can be the liquid or so this is an element that is used to moderate the fission reaction or even the reaction like that to control that as goodly as possible because the fission reaction will release a lot of energy, so you have to know how to decrease this type of energy. The changing can be a little bit can be resistant, but of course that sometimes it will be also yes the I would say that the energy that will be released can be very harmful for our material. So it is important to take into account our moderator. The moderator will be the water, the cold water mostly. The cold water will decrease our energy in sort of it will not be harmful and it will be also useful for the I would say that it will control the energy that we are gonna release and that will be used to convert into mechanical work and to electrical energy. So it is important to take into account. Yes, I said that we have the fuel, the charging, the control rod, the moderator, and the last one, this is the reactor vessel. The reactor vessel is an element of our reactor that is just it consists of core, reactor core, reflector, and shield. It also provides the entrance and the exit passage for directing the flow of the coolant. Yes. So the reactor vessel, this is what is used, what is just, I would say, enclose the fission reaction. So the fission reaction is occurring inside of the reactor vessel. So it is important to have, like they said, a very good availability of our coolant or our moderator through the reactor vessel. So yes, it consists, like they say, of the reactor core, the ship, and the what again? This is about the reflector. Yes, so all these elements are very important to control our fission reaction as good as possible. And the types of the nuclear power plant. We have the pressurized water power plant. Yes, pressurized water reactor because mostly this is based on the reactor that we use. You know, the types of the power plant are just based on the reactor. The reactor are different, but about all the elements that are constituted the power plant, it doesn't vary so much. So, yes. Uh, yes, so this is about the difference about the reactor that are using. So for the pressurized water reactor, this is the same. In fact, this is the first definition that we gave about the nuclear power plant, just to use the energy that is released from the radioactive materials due to fission reaction and to use that to heat the water and convert the I would say the steam that is released from the water after the heating of the yes, so the energy that will heat the water to convert it into mechanical work and then to electrical energy. Yes, so this is the yes, this is just the most nuclear power plant that is used. So the pressurized water, we're gonna heat the water to convert that to steam and then to release that. Excuse me, yes, to release that and convert that into mechanical energy. And then you have the boiling water, that is the second. The boiling water is just used to, I would say that this is about the moderator. The fuels will be just the fission reaction. So the fission reaction will release some of the energy, the heat energy, and this heat energy will be converted directly into mechanical work instead of heating the water. The water now is just playing the role of the moderator or even of the coolant. The water will be at a certain temperature, mostly that will be cold because you have to yes, to control our reaction as good as possible. And then it will be used to moderate the fission reaction for what there will not be any accident like that, because you know it is really important to control that. As you can understand, it is very dangerous and harmful for the human beings, and also radioactive. So yes, and we have also the heavy water and moderating can do. Yes, moderating can do. This is Canadian deuterium uh, unit. Canadian deuterium, some things like that. Unit. I mean, this is unit. Uranium, yes, uranium. Excuse me. Canadian deuterium uranium. So this is a kind of the uranium that was just found in the Canada or some things like that, and the heavy water cooled and moderating can do. And in this reactor, natural uranium is used as fuel, and heavy water is used as coolant and moderator. Yes, the heavy water is passed through the. Yes, we use the heavy water as the. Yes, the heavy water as the coolant or even the moderator, and we use the uranium. This is now about the natural uranium. Like I said, there is two types of the uranium. You can just use the natural uranium, and we can use an uranium that you're going to put in some of the conditions like that for what you get another kind uranium that you can control as good as possible, or even uranium that will yes, make the control reaction a little bit less at these types of the nuclear power plant. We are using the heavy water. You can guess why? Because of the fact that we use the natural uranium, the uranium that we just get from the nature. So of course that it is with a very high fission reaction, that high coefficient of the fission reaction. It is very high, and you have to use the heavy water as moderator for this reason. And after that, you have what? The gas cooled reactor. For this, we are using just yes, the fuels and the uranium as fuels, but the moderator that is used is just the gas. Yes, but for the rest, the generating steam in secondary circuit like the power, the power, just the pressurized water reactor, it can be directly used into gas turbine. Yes, so yes, the heat. Yes, in fact, after the fission reaction, the gas will just freeze our reactor. Yes. So, and then we have to know that the force, the heat energy that is released by the fission reaction and the gas will be very far from each other, from each one at home. So it is really important to know. The gas is used just to freeze, to cool our reactor. So it is good as the. So this is a process that will occur just in the separated moment after the fission reaction. Just one time you have to wait, and then the gas will just be used for cooling the reactor. Do you understand? And then after that, the fission will just occur again. Yes, so this is at two times. Do you understand? This is not at the same time that the fission reaction will occur that we are going to use the moderator. So then we have the, yes, I talked about the pressurized water, the boiling water reactor, the EV water, and the moderator can do, and the can do for Canadian deuterium uranium. And I talked about the gas cooled water, and the gas cooled reactor, excuse me. And now I'm going to talk to you about a reactor that is not using any moderator like that. So this is called the fast breeder reactor. Fast breeder reactor. So it is, yes, a reactor that doesn't use any moderator. So it is just working continuously like that without any moderator. Of course, we are gonna just shut down that using some of the elements like that, like for example the nitrogen or some things like that. But yes, I would say that the fission reaction is just occurring continuously. Yes, and then we have the liquefied metal reactor. Yes, the liquefied metal reactor is using some of the I would say the molten metals like that for as the moderator. And yes, mostly this is about the sodium because the sodium has a lot of I would say a lot of properties that can be used as moderator the for a reactor, a nuclear reactor that is occurring like that. So the sodium, like they said here, the sodium the sodium is more suitable coolant as it has the low absorption, the low melting point, high boiling point, high specific heat, and the high thermal conductivity, and considerably cheaper in cost. For these reasons, we use the sodium as coolant or moderator for the liquefied metal reactors. Yes. So yes, this is the end of our lesson. I will just say that see you tomorrow, and thank you for listening.